Hi guys, welcome to another video by Darklinks Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 8.1 notes, solving algebraic equations using balancing method. Balancing method is honestly the only method I know of how to solve algebraic equations. Now, most of the equations that we're going to be solving are one-step equations. A lot of them can actually be done in your head. However, we are going to show you how, or the proper way to show your work. So whenever the problems become more advanced, when you're in 7th grade and 8th grade and on, they become easier because you know the steps to take. So we've got a couple vocab terms to define. Our first one is algebraic equation. These are statements where two mathematical expressions are equal. A statement where two mathematical expressions are equal. So a quick example of this would be x plus 5 equals 8. So I have an expression on the right side of the equal sign, and I have an expression on the left side of the equal sign. So that means everything on the left is the same thing as the stuff on the right. They may not look the same. Our second vocab term, solution. Solution is a value that makes an equation true. Again, a value that makes an equation true. When, actually probably shouldn't have put a period there, when substituted for the variable. So a value that makes an equation true when substituted for the variable. So quick example. Let's look at the equation we wrote in our first definition. So x plus 5 equals 8. So the solution would be whatever x is, or whatever x needs to be to make this true. So if this is the same thing as 8, I need x to be whatever it needs to be to add to 5, and I would have to get 8. So in this case, what would x need to be to make it 8, to make both sides the same? Well, x would need to equal 3. So x equals 3 is the solution. And this is not showing any work, so this is not going to help you on a more advanced equation. All right, so let's start with equations with addition. We're going to go through addition, subtraction, multiplication, and division, and show you the step-by-step rules and process to solving them. So first, for addition equations, we need to know what the opposite is. So the opposite of addition is subtraction. And besides knowing the opposite of addition is subtraction, the primary thing we need to know to solve any equation, no matter how advanced, is what you do to one side of the equal sign you do to the other. So again, what you do to one side of the equal sign, you have to do the other. All right, let's get started. Our first practice problem is x plus 5 equals 8. So we're going to show you the work it takes to get that solution without guessing and checking, because that's not going to work on harder examples. Sure, it works on this easy thing right here. So we've got x plus 5 equals 8. Now what I like to do whenever beginning is split the equation down the middle, so down the equal sign. It's our balance beam, so everything on the left is the same as on the right. What you do to one side, you have to do to the other. And our goal is to get the variable by itself. So that means everything besides that x needs to go away. And how do I make it go away? I do the opposite of whatever they are doing. So if I see addition, I do the opposite, which would be subtraction. So let's try that. So I see x plus 5. The opposite of adding 5 would be subtracting 5. And again, our golden rule, what you do to one thing, you do to the other. So what you do to one side of the equation, you must do to the other. So you would have to have minus 5 on this side of the equal sign and minus 5 on the other. Now what's going to happen when you do the opposite? Things cancel out. So when I subtract 5 from that positive 5, x is left all by itself, exactly what I wanted to happen. Now, what happens on the right side or the other side is going to get me my solution, if it's a one-step equation like this. So 8 minus 5, we're going to get 3. So our solution is x equals 3. Now, it is good practice to check yourself. If you think x equals 3, go back and see if it actually works. Is 3 plus 5 8? Yes. Our next example, 18 equals 7 plus e. Our goal is to figure out what e needs to be to add to 7 to get to 18. So again, I'm going to draw my line to show our balance. Whatever I do to one side, I have to do to the other. So if I want e by itself, I need to get rid of the 7. So what am I doing? I'm adding the 7 to the e. So the opposite of adding is, again, subtracting. What I do to one side, I must do to the other. All right, let's focus on the side with e. So the opposite of adding 7 and subtracting 7, well, that's going to cause those to cancel out, leaving me with just e. And e is going to equal, let's work on the other side. 18 minus 7, you get 11. So I have 11 equals e, or e equals 11. It really doesn't matter which order you write it. Equals means whatever's on one side is the same as the other. So I can write 11 equals e, or e equals 11. Our next one, 15 equals x plus 3. Our goal, again, is to get the variable all by itself. So that plus 3 needs to go away. So x can be by itself. So we're going to split our equation down the middle. So I'm reminded what I do to one side, I must do to the other. So the positive 3 needs to go away. What's the opposite of adding 3? Again, subtracting 3. What you do to one side, do to the other. All right, let's work on the right side first. So the opposite of adding 3, subtract 3, that's going to make those go away, leaving you with x all by itself. That's our goal of solving any equation, no matter how hard. The other side, 15 minus 3, it's going to be 12. So I get x equals 12. And again, it might be good practice to check yourself. So if I substitute 12 back into the equation, it should be true. So 12 plus 3, is that 15? Absolutely. So x equals 12 is our solution. Let's move on to equations with subtraction. So first, we need to note what the opposite is. The opposite of subtraction is addition. So anytime you see subtraction, to undo it, you need to add. So first, we've got k minus 8 equals 11. So this is saying something, take away 8, is going to be 11. What is our goal? Our goal is to get variable all by itself. So what needs to go away? The minus 8. So let's split our equation in the middle, down the equal sign. All right, again, what's the opposite of subtracting 8? Adding 8. And if I do that, they're going to disappear. What you do to one side, you must do to the other. Let's work on the left side first. Again, opposites. Negative 8, if you add 8, guess what? They're gone. They're going to cancel each other out, leaving us with our variable all by itself, exactly what we want. All right, the opposite side, 11 plus 8, 19. So again, when you do it to one side, it cancels out something, leaving you with one step closer to the answer. The other side is going to essentially get you your answer. So again, what you do to one side, you have to do to the other. So our answer is k equals 19. And I could check, is 19 minus 8, 11? Yes, it is. Let's do another. Our next is 14 equals x minus 5. So what minus 5 is 14? So let's split our equation down the middle. What do I need to do? I need to get x all by itself because I want x equals the answer. So what needs to go away? This negative 5 or minus 5. So what's the opposite of subtracting 5? Adding 5. What you do to one side, do to the other. All right, let's work on the right side. Negative 5, positive 5. Opposites cancel. That's what's always going to happen. So it leaves our variable all by itself. There's nothing else. The other side will get us our answer. 14 plus 5, 19. So we're saying 19 minus 5 is 14. And yes, it is. So x equals 19. That is our solution. Last one for subtraction. We have 10 equals x minus 8. So something minus 8 is 10. Yes, I know that you probably know that 18 minus 8 is 10. However, we're just beginning. We need to learn our rules and steps while they're super easy. So whenever we have much larger equations, we're not lost. And what do we do? All right, so our goal to get the letter by itself. So what do I need to get rid of? I need to get rid of that minus 8. It needs to go away. It's bothering us. So what's the opposite of minus 8? Plus 8. What you do to one side, do to the other. All right, minus 8 plus 8, gone. That leaves us our variable, x, equals, what is our answer? 10 plus 8, again, 18. So yes, our answer is 18. But the purpose is we need to learn these steps while they're easy. So when the equations become hard, you're not crying because math is horrible. No, math is really fun. This is amazing. All right, let's move on. Our next section is multiplication. So first, we need to know what the opposite is because, again, solving equations, you always do the opposite of what they're doing, and you do it to both sides of the equal sign. So the opposite of multiplication is division. So if you see multiplication, you divide. It's like you finally get to do the opposite of what you're told to do. Okay, our first equation is 3x equals 12. Remember, when a letter is smushed up next to a number, it means multiply. So this is 3 times something, or 3 times x, equals 12. So we're going to split our equation down the middle. So I'm reminded what I do to one side, I must do to the other. What do I want to do? I want to get x all by itself. So what needs to go away? The 3. How do I make the 3 go away? I do the opposite of what they're doing. So they're multiplying by 3. So we're going to divide by 3 on both sides. I like to write my division signs as fractions. So just remember that is a division sign, essentially. You could do it like this. 3x equals 12. I could write divide by 3 and divide by 3 like that. It's really up to you. All right, so let's do this one first. When I have multiplied by 3 and I divide by 3, it's going to cancel out because 3 divided by 3 is 1. So I'm left with 1x all by itself. What does x equal? Well, whatever 12 divided by 3 is. So 12 divided by 3 is 4. So x equals 4 is my solution. I can do a quick check. Is 3 times 4 12? Yes, it is. So again, you could write it like this. 3 divided by 3, or sorry, 3x divided by 3 is simply 1x. 12 divided by 3 is 4. So again, 1x equals 4. Next one, 63 equals 9t. Not 90, 9t. So our objective is to get the variable by itself. So t equals, whatever the answer is. So 9 times what is 63? Do the opposite of what they do. So if I need to get rid of the 9, I need to do the opposite, which is divide by 9. What you do to one side, do to the other. All right, so what is 63 divided by 9? That is going to be, oh dear Lord, I forgot. Oh, 7. And what is 9t divided by 9? Simply t, because again, when you do the opposite of what they're doing, it's going to cancel things out. So our solution is t equals 7. And I could check, is 9 times 7 63? Yes. Division. We need to know our opposite, so we can kind of do the opposite rule, basically. What's the opposite of division? Multiplication. So anytime you see division, you are going to want to multiply. So first problem, we have y over 3, or y divided by 3, is equal to 4. So what divided by 3 is 4? Our goal is, again, to get the y by itself. So what needs to go away? This divide by 3. What's the opposite of divide by 3? Multiply by 3. What you do to one side, do to the other. So why does this cancel out? Well, if I'm multiplying fractions, for example, I would put my whole number over 1, right? Well, 3 and 3 have a common factor of 3. 3 goes into 3 once, 3 goes into 3 once. Notice everything cancels out. Again, when you do the opposite of what they are doing, it cancels and goes away. So what am I left with? I'm simply left with 1y. It is equal to, what is 4 times 3? 12. So our solution is y equals 12. Next example, we have 11 equals r divided by 7. What do I want? I want to get the r by itself. So what needs to go away? The 7, or the divide by 7. So what's the opposite of divide by 7? Multiply by 7. What you do to one side, do to the other. So the 7s are going to cancel, leaving me with r. What does r equal? Well, 7 times 11 is 77. Let's do a quick check. Is 77 divided by 7 11? Yes, it is. All right, we've got just a few more examples. The next section, we're going to deal with adding and subtracting fractions. All right, first, we've got x plus 1/2 equals 1 3/4. So our goal is to get x by itself. I want to know x equals something. So what do I need to do? I need to get rid of the plus 1/2 or the positive half. What's the opposite of adding? Subtracting. So we're going to subtract 1/2 on both sides. So opposite of adding 1/2, subtracting 1/2, they go away, they cancel, leaving me with x. What does that equal? Well, whatever 1 3/4 minus 1/2 is. Now, I technically don't need a calculator to do this. However, I'm going to instruct you on how to type in mixed numbers using this brand of calculator. So if I were to do 1 3/4, I would type in 1, ABC, 3, ABC, 4. So 1 3/4. And we're going to subtract 1/2. So 1 ABC 2. And we get 1 1/4. So we're saying our solution is x equals 1 1/4. So if I double check, I should get 1 1/4 plus 1/2. It should come out to 1 3/4. All right, one more on this section. We have 2 5/7 is equal to p minus 2/7. So my goal is to get the variable by itself. So what do I want to do? I want to get rid of the 2/7. How do I get rid of the 2/7? I do the opposite of what they're doing. So I'm going to add. And if I have not made it clear yet, you always add, subtract, multiply, or divide by the thing you want to get rid of. So if I want to get rid of the 2/7, I'm going to add 2/7. And again, you do it to both sides. So again, over here, I wanted to get rid of the positive 1/2, so I subtract 1/2. And before, just on a couple other random examples, we'll just go right back to the beginning. I wanted, well, actually, that's about midway. I wanted to get rid of the 3, so I divided by 3. Always add, subtract, multiply, or divide by the thing you want to get rid of, so the letter can be by itself. All right, let's continue this. 2 5/7 plus 2/7 is going to be 2 7/7, which is 3. And not that I'm encouraging the use of a calculator. Again, just going to show you how to type in mixed numbers. So 2, ABC, 5, ABC, 7. So that's going to be 2 5/7. And to add 2/7, 2 ABC, 7. And you're going to get 3, of course. All right. Minus 2/7 plus 2/7. Because it's the opposite, they're going to cancel, leaving me with p. So our solution is p equals 3. If I take 3 and subtract 2/7, I'm going to have 2 5/7. We have 3 more examples. So now we've got a mixture of multiplying or dividing with fractions. Our first example with this is 8p equals 3/4. So 8 times something is 3/4. How do I do this? Well, I want the variable by itself. So what needs to go away? The 8. How do I get rid of 8? I do the opposite of what they're doing. They're multiplying by 8. So we are going to divide by 8. And since I have a fraction over here, I'm going to use a division sign instead of a fraction bar. So we're going to divide by 8 on both sides. So it's 8p divided by 8. The 8s are going to cancel, leaving us with 1p. What's 3/4 divided by 8? 3/32. So p is all by itself, so we are finished. P equals 3/32. All right, last two. We have 4/3 times y equals 36. I'm going to show you 2 different ways to do this. Why? Because technically we have a fraction and we're multiplying, by a letter, there are two different things you could do to get rid of that fraction to get the variable by itself. So first, actually let me write it over here. 4/3 y equals 36. We want to get y by itself, so what needs to go away? The 4/3. Well, since we're multiplying by 4/3, the opposite would be dividing by 4/3. Again, we have to do that to both sides. So 4/3 y divided by 4/3. We did the opposite. Those are going to cancel, leaving us with y. That's always going to happen. Never takes any work. Thank goodness. We're already doing enough work. 36 divided by 4/3. We're going to get 27. So, simple enough, right? So it's like, why do we even need another way to do it? Think about this. We're multiplying by 4, and we're dividing by 3. So what's the opposite of multiplying by 4? Well, dividing by 4. What's the opposite of dividing by 3? Multiplying by 3. So what's the other way? It is multiplying by the reciprocal. So what does that look like? Looks like this. I want to get rid of 4/3. Again, the opposite of multiplying by 4 is dividing by 4. The opposite of dividing by 3 is multiplying by 3. So if I take that fraction and multiply by the reciprocal, guess what happens? Cancel, cancel, leaving me with y. Now again, what I do to one side, I must do to the other. So again, we're multiplying by the reciprocal, 3/4. So 36 times 3/4 better be 27. And it is, of course. So again, y equals 27. So why would you want to do this? Notice it could be seen as faster. I mean, it's about the same, pretty much about the same amount of work. The only issue with this is learning to multiply by the reciprocal might take a little bit more than simply memorizing to do the opposite of what they do. All right, last example. 27 equals 2/3 x. So 2/3 times something is 27. So notice we're multiplying by a fraction. We're going to do both ways. What do I want? I want the variable by itself. I want x by itself. What needs to go away? The 2/3. So they're multiplying by 2/3. So the opposite of that is dividing by 2/3. Do it to both sides. So when I do the opposite, they're gone. I'm left with x. What does x equal? Whatever 27 divided by 2/3 is. Oops. 40.5. So x equals 40.5. That's not a half. I must be very tired. That's better. Just worried about myself for a moment. All right, so how else could I do that? I could multiply by the reciprocal. So if I multiply 2/3 by 3/2, again, do it to both sides. 3's cross cancel, the 2's cross cancel, and I'm left with x equals, what's 27 times 3/2? It better be 40.5. Let's just check. And it is 40.5. All right, so real quick, your goal is always to get the variable by itself. To do that, you must do the opposite of what they do with the number you want to get rid of. So in this example, if you want to get rid of 8 and they're multiplying by 8, you do the opposite, which is divide by 8. That will always get rid of that number. When you do it to the other side, it's usually going to get your answer. These are all examples of one-step equations. Eventually, we're going to do two-step equations. Two steps means there will be 2 steps to get the letter by itself. That means there's going to be something else with the variable on that side, and you need to do the opposite to get rid of it. So you can eventually get, again, the letter by itself equals your answer. I hope this has helped seeing how to solve simple one-step equations. If it hasn't, there's a lot of information out there. I hope you find what you're looking for. Y'all have a great day.